determine if the sequence converges or diverges. If it converges, determine its limit. Here we got 3, negative 6, 12, 24. 3 times 2 is 6. 6 times 2 is 12. So it looks like a geometric sequence. Let's see. Then common ratio is just second divided by first is negative 2. Let's confirm. What is third divided by second? That's negative 2 as well. So this is indeed a geometric sequence with common ratio r equals negative 2. So geometric sequence, common ratio negative 2. We just confirm dividing second by first and checking with others. And we know that in a geometric sequence, if the common ratio is in between negative 1 and 1 inside here, then the sequence converges. Otherwise, the sequence diverges. In this case, negative 2 is way outside. So diverges because it's a geometric, we already said that, geometric sequence with common ratio r equals negative 2, which is bigger than, in fact this is bigger than the absolute value of r, or we can say, okay, we know that it's just outside of this, okay, which is less than negative 1, maybe outside here, and here diverges. Looks like same thing here, because 2 is 2 over 1. 2 times 2 4, 4 times 2 8, 8 times 2 16. So looks like a geometric sequence. So let's confirm that. Common ratio would have been then second term divided by first, negative 4/3 divided by 2. If we simplify negative 4/3, this becomes 1/2. 2 goes 2 times, so negative 2/3. Let's look at the same thing from third and second. Third 8/9 divided by negative 4/3. If we simplify, we're gonna get negative, this flips, so 3/4. 4 times 2, this negative sign, 3 times 3, so negative 2/3. So we got the same thing. So this is indeed a geometric sequence with common ratio negative 2/3. And if we look at this, the case, so negative 2/3 is here. So inside negative 1 and 1. That means this sequence converges. Okay, so converges being a geometric sequence with r equals negative 2/3, okay, which is in between negative 1 and 1. Okay, r is in between 1 and negative 1. Okay, let's do the same thing here. It looks like 8, 4, 2, they are decreasing. So looks like a geometric sequence again. So let's confirm that. So second divided by first is negative 1/2. Third divided by second is also negative 1/2. Again, that is inside negative 1 and 1. Negative 1/2 somewhere here. So converges being a geometric sequence with r negative 1/2. Converges being a geometric sequence, r is negative 1/2. In fact, if we read the question, if it converges, then determine its limit. So the first one diverges, second one converges, and the common ratio is less than, in between negative 1 and 1. So in this case, they are heading towards 0, in fact, being smaller and smaller. So limit, if I denote the general term by an, when n goes to infinity, that will be 0, because the common ratio is in between -1 and 1. Okay, for L, and is okay, this is m. It's the same thing for both, in fact, for both, same thing. Final question is -1 to the n plus 1. So whenever we get -1 raised to power, we're gonna get negative, positive, positive, negative. I don't know, let's check. Let's write a couple of terms here. And generally when it does not say anything, we start from n equals 1. So when we put 1, 1 plus 1, 2, -1 is squared, positive 1 over 1. So the first term is 1. How about second? That means n equals 2. So 2 on the bottom, 2 plus 1, 3, -1 raised to 3, -1 cube is -1, so -1/2. Let's look at the third. Okay, 3, -1 raised to 3 plus 1, 4, -1 to the fourth is +1. So this one in fact gives +1, -1, +1, -1, and the bottoms are increasing. Here we got, what is this now, 4 plus 1, 5, so -1. Okay, what type of sequence is this? If we divide second by first, we're gonna get -1/2. If we divide by this, we are not gonna get the same thing. It's not a geometric sequence. But if we list them here, so the first term is 1 and -1/2, so here is 0, let's say. Here is 0, -1/2 will be then here, then 1/3 is here, and -1/4 is here, would have been 1/5, even closer. So these numbers are first, second, third, fourth, fifth. Okay, and they are in fact decreasing towards 0. So this thing in fact converges. Just examining the terms. Okay, this will be 1/5, -1/6. If we look at closely, the bottom is increasing. That means this is gonna go to 0, as you can see here, coming towards 0 slowly. So converges to 0.